Hello and welcome to this video about the jumble function. This function is the reverse of sort and creates a list of randomly jumbled numbers. In this example, a list of numbers from 0 to 19 is jumbled up so that each of these numbers appears only once in this jumbled list. There are many applications for this function, some of them being for bingo, lotto, and card games, where a jumbling up of numbers of this type is required. So let's take a look at the general algorithm necessary to do this. Firstly, an ordered list of numbers is created. The list can grow to any length, but in this case there are 20 numbers in it. So we have an index variable called I that works its way up the list, and starting at the first element. It starts at 0 because this is the index number for the first element in most programming languages, including C and JavaScript. A second index variable called X is randomly selected from a list of numbers contained in the blue ellipse. Notice that in this case, the first element is included in this range. This is so that all possibilities of random jumbling can occur. So X is made equal to one of these numbers given here. And so these two numbers indexed by these variables are swapped. And so the index variable I is incremented and points to the second variable on this list. And X can be made equal to any number in this range here, and X is selected randomly. The range of numbers it can be selected from is decremented by 1. And so X is made equal to this particular number in this range. And so the two numbers in these locations are swapped. So the index variable I is incremented, and X is randomly taken from this range of numbers. Notice that the numbers 0 and 1 that are less than 2 are now in this range. So X is made equal to this number from this range. And so these two numbers in these locations are swapped. And so I is incremented, and X can be made equal to any number in this range of locations. And so X is made equal to the last number in this list. And so these two numbers are swapped. And now to write some computer code that will replicate this algorithm. The first line will be equal to the numbers of elements in this list. And this next bit of code creates an ordered list of these numbers in an array. And so now to start writing the code to jumble them up. The number of elements remaining that X will select from is equal to this variable rem, which is short for remaining, and is initially set to the length of the list. And now to write a loop to make I span the entire list. Now to get the index variable X, which will be made equal to a random integer in the range of the blue ellipse that we saw earlier. This formula gives us this random number. Now we have to swap the element at location I with the element at location X. Then we have to decrement the range of remaining elements and then close the loop. Another thing we would like to do is to adjust this randomly jumbled list so as to be able to write multiple choice questions. Supposing that we have 4 buttons that correspond to a question, then we will have a list of 4 multiple choice answers. The correct answer is in the longer list, but probably not be in the first 4 elements of this list. We'd like to put this answer amongst the first 4. So the correct answer is X is equal to 12, and the correct button is B is equal to 2, which will be the third button and selected randomly from 0 to 3. So then we search through the list looking for the correct answer, 12, and we find it at location j is equal to 9. So then we swap the numbers at these two locations. This algorithm is very resilient and will be able to swap the answer correctly even if it is less than 4, and even if b and j are equal. And so now to write this down as code. Here b is set to one of the buttons. The number 4 may be changed to 5 or 6, but don't make b too large. We're given the correct answer here, and we have to find it on the list. So here is a short bit of code to do this. It keeps incrementing j until the element at j is equal to x. And so now we have to swap these two elements. And so here is an example of some swap code. So I hope that this video has been helpful for you in your quest to study and use the Jumble function.